Okay, so let's take a peek at what you guys did yesterday. And like I said, if you have questions on it, I'm here. Do not hesitate. I did put 3 or 4 that were tricky. I'll open up the worksheet as well. I gave you some hints on the more complicated ones. What is this? I don't want that. Stay in Chrome. Okay. All right. So then open up my teacher Desmos. Let's speed this up. Okay. All right. So I asked you guys to do, I think, like 7 problems. That would be this one. Okay. So let's take a look. Okay. All right. So like I said, if you had any questions or if you didn't have time, that's okay. Let me know. Let me look at some of the hard ones. Well, first of the easy ones. Let's look at, I don't know, 6. All right, so force everybody to go on 6, which would be screen 13. So I'm going to force you guys to go to 13. Okay, so let's see. Look at Sophia's because she does the coloring. So we cut 5 in half, which would be 2.5. We squared 2.5. We got 6.25. 6.25 was supposed to be 4, so we're going to subtract 225. That would be your y vertex. Perfect. Good job. All right. Any questions on this one? If I don't know, I'm not sure if you're in, Devin, but on this one, I see you were factoring it. Be careful with when you're completing the square. You're actually making identical twins. So yes, this is factorable. You could, but these are not twins, so it wouldn't actually work. This would give you the x-intercepts, by the way, which would be -2 and -3. So be careful on that. Hating the same thing on this one. It's not 4x. So go ahead and fix those if you guys are there. It's not 4x. It's half of 4. You want it to be. You want both of those numbers to be half of 5, half of the middle number, half of b. So that's half of 5 is 2. So then each of these would be 2.5. Does that make sense? So that's the idea. So go ahead and work on those. If you didn't put 2.5 inside, go ahead and fix those. Good job. Thank you. And same thing for you, Kennedy, if you're in here. Let me just see who's here. Because, when you guys do these assignments, I actually look at your work. And if I don't see that you're like getting it, I want to give you some advice. So it looks like some of you are getting it and some of you are not getting it. So that's okay.
Can you Eunice?
Yeah.
Can you do one as like a refresher?
Yeah, of course. All right. Let's do let me do this one, okay? I'm gonna jump on your screen. Go ahead and everybody take a look at mine. And I'm gonna write the original equation in here just so I have it. I think that's +4. Let me just look at it again. So this number 6 was +5 +4. Okay, so the idea here is that you're trying to you're not trying to factor it, by the way. You could factor this one, and you get the x-intercepts, right? Because 4 times 1 is 4, 4 plus 1 is 5. But When you want to turn it into vertex form, you want to, this is your goal right here, everybody, Amar. You want twins, right? And I call these twins because they're the same, right? Make sense? That means that this has to be the same as this. My two red squares have to be the same for them to be twins. Because vertex form has twins. So I start off with the inside. I put x squared in the corner. And I don't actually fill in the bottom corner like I normally do on factoring. And this is x and this is x. Now these two together, these two add up to, they add up to 5x. You could tell because on the standard form. And if they're twins, well, that means they have to be 2.5. Four and one add up to 5, but they're not the same number. 6 and negative 1 add up to 5, but they're not the same number. So therefore, half of 5, this would be 2.5 here, 2.5 here, xx. And now you know the top number, which would be 2.5 here, and then 2.5 here. So now you know the twins. Okay. Now, however, this square down here, this comes from both of these numbers. And 2.5 times 2.5 is 6.25. I'm going to squeeze that in there. 6.25, right? But it's supposed to equal 4. So if you were to, it's supposed to equal 4. So you can actually mess with 6. You can say, oh, if I have $6.25, well, if I subtract $2.25, then that will equal 4. And whatever it is that you subtracted, well, that is the number that you're messing with. And this is vertex form. All right, so then I'm going to change that to vertex form. X plus 2.5 squared, and then minus 2.25. So the 2.25 is what I mess with it. So then the vertex is negative 2.5, negative 2.5, comma, I'm sorry. Yeah, it is negative. And then comma negative 2.25. Okay, and I'll explain it again with some questions. But if I actually go to Desmos, and some of you are going to Desmos, and that's fine, you just type it in the equation, and you're finding the vertex. It's cool. I mean, you're getting it, but you're not going to get when you get to higher math, you're going to mess up a lot. Look at this vertex. Whoops, what happened? I messed up somewhere. Okay, I got these numbers backwards. It's 5 and 4. There we go. Look at this vertex. See, it's exactly what we predicted with our calculator. Not predicted. It's what we calculated, right? Now, what you're doing is you're basically all that math you're doing is just to get this coordinate right there. And you could ask, hey, yo, Mr. Kennedy, why are we doing all this calculations when we can just type it in here and just click on it? I said, well, that's, math is not just typing it in and having the computer do it for you. You got to kind of know how it works. All right, so that was that one. So can I get questions on that?
Where did you get the 2.25?
Yeah, so you see how I circled pretend that it wasn't there yet, right? Pretend it was empty. We know that these two blank things equal 5x. And where do I get the 5x? It's the middle number of the original equation of the standard form. The original equation of x squared plus 5x plus 4. So normally when you make a box and you square it, you normally add these two right here and they will give you the middle number, correct? So we're doing this in reverse. So now we know the middle number. So then we're doing it in reverse. We got, well, this 5x came from these two numbers. And these two numbers have to add up to 5. So what two numbers add up to 5? There's lots of them, right? Does that make sense? but we want them to be the same number. And why do we want them to be the same number? Because in vertex form, you have the same thing, right? We have twins, x plus 5, x plus something squared. Um, and Amar, did you say 2 point? Where did I get the 2.5 or the negative 2.25?
No, the negative 2.25.
Okay, got you. I'm sorry. So then I squared. I'm going to change colors to purple. So now that I know the twins, I multiply the twins and I got 6.25 right here, right? But this is the wrong number. It's supposed to be 4, right? Does that make sense? You see right here on my last term? It's supposed to be 4. So how can you make $6 become $4 by subtracting? How much would you have to subtract? You'd have to subtract $2, right? So I subtracted $2.25. So I'm basically saying this equation up here that I circled or rectangle is the same as the original one, except I had to mess with it in order for it to be equal. Okay. So this is something that you had to calculate yourself. You're like, well, it's supposed to be $4, right? Now, Amar, what if it was supposed to be 7? Just pretend that this 4. Just pretend this was 7. Just pretend. So what would you have to do to $6.25 to make it become 7?
0.75.
You'd have to add 0.75. So then you'd have to add 0.75 instead of, right? Make sense? What
Yeah,
it?
but what
Huh?
where would you have gotten the 6.25 in the first
Oh,
place?
when you square the twins. When you square 2.5, so when you put 2.5 times 2.5, you get 6.25.
Oh, okay, okay.
So it's like a little puzzle, right?
Yeah.
And every piece helps you find the next piece.
Uh-huh.
So the first piece is the 5, right? I haven't having a hard time writing with this mouse. So the first piece is the 5. The 5 gives you the 2.5, right? The 2.5 gives you the outside 2.5s. The outside 2.5s gives you the 6.25. And then this extra number will tell you what to do with 6.25. So it's all like a little puzzle. Everything builds on the other one, right? And by the way, what if just pretend that it was 6.25? So would you have to add anything to it if to make it 6.25? Maybe plus 0. So you'd have to add nothing to it. Right? If it happened to be the same number you wanted to already. Okay. All right. And then the best way to do this is to do another one. Right. And I really appreciate the questions, Samar. It makes me seem like I'm, helping and doing something. Can I get another question on this one from anybody on here? And we could do another one too. Now when you graph it, watch when you go to graph it. And by the way, you guys were supposed to graph both, and then that would prove your answer, right? So you graph your vertex one and then your standard, and it should be the same graph, and you could tell. Now, if you had messed up, you would see two graphs. See that? So if you did the wrong thing, if any little piece was wrong, you would see two graphs. You should only see one graph, even if you're off by 5 cents. Well, I guess that'd be 25 cents. Okay. All right. Let's look at another one, and not another one that's super hard. Still, let's do another one. Let's look at 5, because 5 is just I just give you like a smaller number. And I know you guys are all stuck on the screen, so let's look at 5. All right, so we're gonna go to 5. Pasting 5. Here we go. All right, so we're at 5, and okay, Okay, now I'm going to write the original function just so I remember it. Number 5 was 121. Okay. So it was, the original one was, I guess I should ask you guys to write it here too, right? It was x squared plus 2x and then plus 1, right? So then the so what do these two have to add up to? They have to add up to 2x, right? So they have to add, so therefore each one has to be 1, right? And then 1 times 1 is 1, and 1 is already 1. So it's like perfect. It's already what I want it to be. So then you would have to add nothing to it. Okay. This one you didn't have to like mess with it. And I gave you one of these just so you can see that sometimes it's already what you want. Okay. All right. Now let's look at the hard one. Number 3. Actually, I think we did number 3 together. Let's see, number 7. So screen 7 would be okay. Screen 7. All right. Let me Shift's got a cool way to do that. Let me see. All right. Let me see somebody who did all of the work here. All right, Sophia, thank you so much for the way you do it. It really helps me to help out. Can somebody read me the original one so I don't have to go back and forth? Is it 6x squared, right? And then what else?
Plus 12x plus 18.
Plus 12x plus it. Thank you. So I told you guys, hey, get rid of that 6. Get rid of the first number. And I gave you all numbers that you can divide by 6. You just make it simple. So if we divide everything by 6, we're going to get 6 times x squared plus 2x plus 3. And you're like, cool. I'm going to cut 2 in half like I did previously. And then it's going to be 1 and 1. Now, 1 is the wrong number. It's supposed to be 3. So we're going to add 2. Now, I reminded you guys that if you are adding 2, you're really adding 2, but you're actually multiplying by 6 because that's what we have to do from the beginning. So then that means we're really adding 12. And that's what Sophia did right here. Okay. So we're adding 2, but we're doing 6 sets of 2. So this box happens 6 times. And then don't forget to add the step value and the 6 in the beginning. Okay. So you're basically multiplying by 6 to whatever you add or subtract, and also bringing the 6 back into the beginning of the function. So then the vertex of this would be negative 112. The vertex would be negative 1, 12. It takes a little practice, guys. Even 1 or 2 days is sometimes gets you going, but you need to really get. All right. So here, Amar, let's get you doing that one. So first you divide everything by 6, right? Because what you don't want is a 6. You want it to be x squared. You don't want it to be 6x squared, right? You want twins that have x only, not 6x squared. Travis, is that what you? I can hear you. All right, so let me do it on this screen, on a better screen, so that I can draw better. Okay. See if it's opening up. So I definitely want to help you and support you guys. So we'll take our time on this. If you need another. Actually, today's assignment is the same thing, with a little more guided support. Okay, so let me do this one. Okay, so we had 6x squared, and then Nathan, what was the rest of it? I totally forgot again.
Plus 12x plus 18.
Plus 12x plus 18. So our goal.
Just unfreeze my screen.
a goal is this, right? So what we want to do is we want to get rid of the 6 because we want to make twins and we don't want a 6. So that means we're going to have 6 times, I'm going to put in parentheses, x squared plus 2x plus 3. Now I can make my twins. And don't forget that you're going to be multiplying by 6. Whatever you're going to do here, you're going to multiply by 6. And inside, we're going to put x squared, x, and then this is going to get cut in half. It's going to be 1x, which will be 1 here, and this will be 1. Now, 1 is supposed to be 3, so we're going to mess with it by adding 2. Now it's 3, right? 1 plus 2 is 3. So we are going to put the twins in here, bring in the 6, and multiply what you added, and then this is your function. And then the vertex is -1, 12. Okay. Now I went through it a little fast, but go ahead and ask me like which piece, how did you, why did you, when did you, how would you know to do that? Can you guys ask questions like that? Or I don't understand that this part. So first step, get rid of the 6, right? Rid of 6. Why do you want to get rid of the 6? Because you want twins with no numbers, right? Second step, make twins. Right? Third step, add something, right? Add or subtract to get this number, right? And the last step is multiply that number by whatever you divided by, right? By 6. And then that's going to be the number that lands right here, which was 2 times 6. This one. Okay. All right. It takes practice, everybody, and take your time. Just kind of go through it. And you could check your work. Okay. Let's see. Can I get a question? I'm going to unblock you guys. And any of these 10, and you tell me, and we'll do it together. Okay. And then I'll give you guys the Khan Academy, which is still the same thing. So it's not like a separate, different assignment. Let me go here, pacing, stop. Okay, so look at the problem set and see which one you think. Okay. And Hannah, I'm not sure if you're in here or not. It should be x plus 1 because the twins are positive, right? Make sense? Inside the parentheses. And you know the twins are positive because the middle term is positive, right? Thank you, right? So whatever the middle terms is, that's what they're going to be, right? Good job, okay? And if you're watching this recording later on today or tomorrow, like some other people are watching the recordings later, go ahead and make sure that you're pausing it and seeing everything. And this is why I record it, so I can show them. And if you guys have time, look around and see which one that you have a question on. Let's see. The ones with negative could throw you off a little bit, so I'll wait for you to ask me. Because they kind of flip the signs.
Mr. King, how many of these do we have to do?
Well, you were supposed to do these yesterday. So you got to do, so on 2 days ago, we did 1, 2, and 3. And then yesterday, you were supposed to do 4 through 10. See that? Tuesday work on problems 4 to 10. Okay. I mean, in order to get good at something, you got to do it a few times, and then you have to like learn from misunderstandings. Uh, I don't know about you, but I don't really get good at something just by doing it one time. It takes me like sometimes it takes me a lot of times. Now you don't have to become a master at this, right? You just have to be okay at it. Just have to be somewhat understanding the idea behind it. That's all I'm asking. So can I get any questions on any of these while you guys are here? Even the hard the well, I'm not going to say hard ones, but the ones with negatives uh, could mess you up. And it's there's nothing like tricky about it. You just have to do the same thing. Let me see. Let me see how you guys did on the last one. Number 10. So it's upside down. Okay. All right. Let's see. I'll pick on Sophia again because. All right. Sophia, if you're here, can you, next to the vertex function, can you write like the standard form function, the original, like just right next to it? I could see if it works. Well, maybe you're not here today. Okay. Or actually, there are two Sophias. Oh, you are here. Oh, yeah. Okay. Thank you. Okay. So the first one on number 10, if everybody just takes a peek at that one, we need to get rid of the -2, right? So in order to get rid of -2, we got to divide by -2, which would make everything become opposite sign. So -2, 8, and 4. So if you have -2x squared plus 8 and then plus 4, it's the same steps. First, we got to get rid of this -2 because we don't want any. So then everything turns opposite sign. Now we can make our twinsies. I used to hate making twins because like I can just do them in my head, right? This is going to be 4, but 4 is the wrong one. 4 really has to equal -2. That means we have to subtract 6. And don't forget, you got to multiply it by -2. That's the part I always forget to as a kid. So then the equation would be this, and then the twins, and then my plus 12. There, I almost put -12. There you go. So that's how it would be. Now I would do these in my head, and I would get a lot of them right, but then I would mess up on one or two because I was trying to go too fast.
Mr. Canales, can you do number 5?
Yeah, can you read it?
I just want to make sure I did right. Yeah, so x to the second
squared.
Wait, no, sorry, number 6.
Yeah, go. No, sorry, go ahead.
So x to the second plus 5x plus 4.
Okay, so this is a 1, so we don't have to divide anything, so it's ready to go, right? So we can make twins, right? So then this is 5, so we're going to cut it in half and put it inside, right? Oh, is this the right one? Yeah, I think that you read it to me. Therefore, this gives you the outside, right? Now, 6.5 times 6.5 with a calculator is 6.25. Now, 6 is the wrong number. It's supposed to be 4. So that means we can mess with this number, right? We're going to subtract $2.25. And now these two together equal what? 4. So now we can put the twins, right? This is one twin. Here's the other one. And then bring in whatever you mess with it. So what I circled here is exactly this times this, right? That's what it says here, and then minus this. So I'm basically this. I'm actually saying what this is saying, and this is saying what this is saying. So basically, I'm saying the same thing over and over. It just looks different, right? So this is saying this, and this little rectangle is saying this. So this is standard, and this is vertex form. And thank you, Amar, for asking, right? You really want to ask here, guys. I want to really encourage you, like do it. That's what I'm here for. And you can check, right? And you could, when there's a negative, you can see the graph's upside down, right? Well, it's not technically upside down. Now, if in case you forgot to put the -2, guess what? You'd have the correct vertex. See, they both of my equations have the vertex. They both have the same one. So if your sole job was to get the vertex, well, it doesn't really matter what number you put here in the front. It's still going to give you the same vertex. But your equation, see, it doesn't matter. It's still the same point right there. So the a value doesn't change the bottom of your stairs or the top of your stairs. It doesn't. It just keeps it tight. It keeps it what's the word? Locked in there. Okay, so I'm going to be here to take your questions, right? So for Khan Academy today, it's actually easier than yesterday's. And it's easier because you've practiced a little bit. So go ahead and log into Khan Academy. And before you guys get started, let me just tell you the stuff, and then you guys can get rolling. And I'll stay with you as you go into it. You're probably going to finish this like in 10 minutes, as soon as I log in, computer, activate. I guess I have to click on the right button. I tried to reformat my computer so that it could be faster. Then now it didn't save all my login info. Okay, so the assignments that I have for you. Let me go to assignments, manage, I think. So let's start with the easiest one called the intro. And the intro, all you got to do is add the number that it should be. Ready? So take a look at mine so that you can get to it. It'll take you literally seconds. All right, here is the middle number, 2. So we're going to cut that in half, 1. So cut 2 in half is 1, and then put 1 times 1. And that's what you need to have. So it's asking you, what number should the third one be? So go ahead and do those. All right, the middle number for mine is -16. Half of that is 8, -8. And -8 times -8 is 64. So I need that number. And basically, what I'm doing is, if you imagine I'm making the twins in my mind. It's doing this, right? Basically it's asking me for this number right here. So everybody try it out. And then, so it's basically asking me for this number, which is called the constant, right? The number that doesn't change. Give me a heads up when you got your 4 in a row, even if it's on the text or on the chat, or if it's on, just let me know verbally. So you're basically cutting the middle term in half and then squaring it, right? So you cut b in half, then square it. Good job, okay? Good job, Devin. All right. So you're squaring is pretty simple, right? I'll wait for a couple more. Steam is done. Good. So you're basically just finding out the middle term, and this is why it's easier because I kind of took you guys more, uh, took you more ahead of the game, which is good. I like doing that. All right, let's go to the second assignment just to take a peek at it. You can come back to it. Uh, the second one, let's call is intermediate. Intermediate means like middle. In this one, you're going to do the same thing, but then you're just going to mess with the equation. Okay. So, um, this one we're going to get the twin. Now, they kind of mess with this a little bit. It kind of throws us off. The twin is going to be 9, and it's already 9. So they want the inside to be 3, and it equals 0. Because it's see, we didn't have to add or subtract anything. So basically, this one's asking you for the twin, the one that goes inside of the parentheses. Okay. This one, we're going to, the twin is going to be half of b, which would be -6. You can put -6. And you can make the twins if you want. Draw it out. You don't have to draw it on the screen. You can just draw it out on your paper. And if you don't have to, if you're comfortable not drawing it, that's okay too. Now this is going to be 36, but 36 has to be actually 50. So we have to add something to it. I'm going to add 14 to it to make it 50. So that's going to be 14 right there. This is going to be -7. I can do it in my head. And I need to add, so 33. Okay. So 33, so it's supposed to be 33. So I'm going to subtract -16. Now it's on the other side of the equation, so it's going to be +16. That's weird. I'll leave this one. I'll leave this one open. It's kind of like almost like backwards. So let me know if you have any questions on this one and any of these. And then let me know when you are done with this one.
Done.
Done? Okay. And did were you did okay, Nathan, when it asked when it had the equals on this side?
Yeah.
Yeah, okay. So on this one I almost typed in -16, right? Because I had to subtract 16. Except
Yeah, I did that.
yeah, the empty spot is on the other side of the equal sign, right?
Yeah.
So that therefore we have to add 16. So basically it would be like x -7 squared -16 equals 0, right? But
Yeah,
they wanted you to, they wanted this number over here.
So you add 16.
So you add 16, yeah. And basically they're gonna solve this. From here they're gonna get the they're gonna find the x-intercepts. Watch. And what times what is 16? Right? So square root, right? So x -7 equals 4 or -4, right? And that's why they put the 16 on the other side, because then it's like one step to solving it, right? Okay. All right. I'm here, guys, so ask me. If you're ready to go for the third one and the last one, this will be the last one, Nathan. Will be the third one, which is just the same thing. I think it's going to be asking very, very similar. By the way, completing the square to me was actually one of my one that I really understood. I'm like, oh, okay. Like I understood why we were doing it. The mechanics made sense. But it took me some time though, right? Yeah, so the third one is the same thing. So 3.5. 3.5 squared is hey guys, I'm here. Ask me for for help. That's what I'm here for.
I'm at. Yeah, I can't take this speed anymore.
You can't what?
Speech just really confusing. Feels like.
Yeah, what you could do too, if you want to take a break, Travis, you could take the hints, and then it has a step by step of how to do it.
Yeah, I think I gotta get out of here.
It's fine. It's fine. Totally fine. Yeah, take a break, but when you come back to it, take the hints and like study each one at a time.
All right. Well, see ya.
Okay. See you tomorrow. All right. Let's see. Okay. Anybody else need any help? Remember, what we're doing is we're converting standard form to vertex form by messing with it a little bit. Remember, and when you convert it to vertex form, you want to have twins, right? That you want to have two of the same thing, because that's what vertex form looks like. That's the whole point. So go ahead and ask me for help. I'm here. I'm going to do this one here on the screen, so then I can figure out how to draw on this. This one, okay. So I'm going to make twins here. X squared, x. Now these two have to add up to -7. Therefore, they got to be 3.5. So that means this is 3.5. And this is going to be 12.25. Now these together have to be actually 12, so it means we're going to subtract a quarter. Like this.
Is this the third one?
Yeah, and I think that the third one is the same as the second one, but probably easier. But I'm trying to make it clear. It's getting a little messy with this guy. There we go. So this together is supposed to add up to 12. So we're going to subtract the quarter. Why can't I write? There we go. So that means they're going to have x plus 3.5 squared minus 0.25. So these three Khan Academies are actually easier than the ones I gave you yesterday, except that here we go. There we go. Opposite. It's opposite, right? Opposite. A lot of arrows. Well, the arrows are for you. I wouldn't actually need the arrows. You just because I look at them, right? I'm telling you where I'm looking. All right, let me log into my Khan on the other computer and see how you guys are doing. Okay. There we go. Okay, good job. Sophia's got the first two. Okay. All right. Steven's got the first two. Devin's done the first two. Nathan's done their two. Owen, Mars got them. Shiv's getting those. Okay. When the blank thing is on the right side of the equal sign, make sure to type in the opposite of whatever you're adding or subtracting, because it's on the other side of the equal sign. Okay. So when the little blank square is on the right side of the equal sign, write the opposite. When it's on the left side, write whatever you are adding or subtracting.
Yes, I'm confused.
Yeah. What number are you doing? Well, show me what you're doing, or tell me what you're doing. Read.
So I'm on the third one.
Yeah.
And
what do you got?
it's asked, so the function is 2x to the second plus 11x plus 15.
Oh, this is yesterday's or the Khan Academy?
No, this is the Khan Academy.
Okay. So, ready? That's what it is? That's a hard one. All right, so we divide everything by 2, right? And now we're going to have 2 times x squared plus 5.5x plus 7.5. Did I write it correctly? 2x squared plus 11x plus 15?
Yes.
Okay. Next, I'm going to make my twins, right? So x squared here, x. What's half of 5.5? 5. That
2.75, I think.
Yeah, so then you're going to put 2.75 in here, right? That means 2.75 goes outside too. Okay, now what is 2.75 squared? Can you use a calculator for that? 2.75 squared.
I think it's like 7.7.
Let's see. Let me type it in my
7.44 actually.
Really? Oh, so this might be 2.75. Oh, I see. You know what it is? I think that Desmo, Khan probably wants you to keep them in a fraction, but let me check. 2.75.
Yeah, because I'm pretty sure I did it right, and I tried to like look at the help section.
Look, it's 7.48. Okay. All right, now we're going to. This is the wrong number. We need to make it 750. So how much do we have to add? How many pennies?
0.02.
Yeah, 2 pennies, right? But we're going to multiply them by what? 2. So we're really going to say 2 times x plus 2.75 twins plus 4 cents. Right? Because we multiply 2 cents by 2 and got 4 cents.
Yeah.
Now, let's see if on Desmos, Omar, can you read me the function again? 2x squared plus 11? And I think it said 15, right?
So it's 2x squared plus 11x plus 15.
Oh, 15, yeah, okay. Okay, so let's see, I got a 2x squared plus 11x plus 15. Okay, I got the correct x, but I got the wrong vertex. I got 12 cents. 12 cents. Let me see. 7.5. 2 points. Well, let me find out what half of 5.5 is to make sure what that is divided by 2. 5.5. Oh, I see. 2.7. I messed up right here. 2.75 times 2.75 is actually 7.5625. This is wrong right here. This piece is wrong. It's supposed to be $7.56 and a quarter. See that? Now it's supposed to be 750. So we have to subtract something. We have to subtract a little bit, right? We got to subtract this amount times 2, right? So it should be 12 cents right there, 12 cents. I'll even erase it to make it clear. So I messed up. I did actually 2.75 squared is not 7, whatever I wrote there, 7.5. It should always end in a 0 or 5 when you're squaring something. Like, let's see this one right here. And you can also,
Yeah, that was still wrong.
this was wrong right there. Now, remember in Khan Academy, it's going to either ask you for the equal, it's going to ask you for the equal sign. Let me change it back to, it's either going to do this, right? Where you have to put it in here, or it's going to give you this with the empty on the right side. So is it asking, is the square on the right side or the left side of the equal sign?
Let me check.
So
there's a square inside the parentheses, and there's a square after the equal sign.
Exactly. So if it asks you for the square after the equal sign, then this number has to be opposite. Because this number always goes right here, right? Right here. Right? And this one was a negative 12 cents, right? 12 and a half cents. Now, they want this square on this side of the equal sign. So how do you move this number over here? You add it. You do the opposite. And that crosses it out and ends up where? So Amar and everybody, when it asks you for the square on this side of the equal sign, it has to be what? It's got to be opposite. Okay. And with Khan, it does them both ways. So you have to like see where it is first. So it's got to be positive 12 and a half cents right here. Now, I wish you didn't do this for this particular exercise. It's okay that it does, but I wish it didn't do it because then it kind of confuses us a little bit. All right, let's see where everybody else is at. So take your time with these. Do them on paper. It'll help you. A lot of people did get 100% on the first 2, and then you're working on the third one. That's it. Tomorrow is Thursday, correct? Okay, so tomorrow I'm not going to add anything new. So I'm going to have time tomorrow to just go over all of the assignments that we have, okay? So tomorrow when we meet, have some questions ready. I'm not going to give you anything new, just more of like, just kind of let it sink in a little bit. And good luck, everybody. You got this.
Thank you, Mr. Quinones. Bye.
Bye. I usually don't want to keep you guys more than 15 minutes. So if you want to just pause it here or continue later, that's fine. Okay. But tomorrow we'll have more time for this. Okay. All right, guys. I'm going to sign off unless you guys have any questions. But if not, tomorrow I'll be here. Take any questions you have. And Amar, thank you very much for asking. I appreciate it. By me helping you, you're helping me. It's kind of works pretty cool that way.